Hi, I'm Kevin Miller at Solve3D. Today I wanted to talk about a couple highly used functions, sampling and thinning, operations that you can perform on some point clouds. So the use case around this, I'll just show you my file size here. I have a really large, well, it's not really large in the grand scheme of things, but a larger tile of a point cloud, 150 megabytes here. If I look at this point cloud, I'll just show you what it looks like first. Little tile of a road and a parking lot, some trees, and say, I don't know, say this file is too big and maybe I'm trying to share it with somebody. I want to thin it down or sample it down to a smaller size. There's a couple of ways to do that inside of Engine. So we're just going to close this. We'll talk about sampling first. So under the Engine workflow, under the point cloud processing category, we can expand that and find sampling. So it's a pretty simple function. You select the point cloud. So we're going to pick area.las, and then the sampling rate is, say for example, if we type in 0.1, that means 10%. So if we do a sampling rate of 10%, the output file that we create is going to be 10% of the size that it was originally, and the points that are selected are sort of random. So it's going to pick 10% of the points at random in the point cloud and give you an output file. So it's a pretty quick function to do this. And if we just execute this, you see it almost finished instantly there. So we went down to from almost 6 million points down to 600,000. So if we exit this and just take a quick look at this, see, actually, while it's loading, you can see it went from 150 megabytes down to 15. So we load that in, and now we got a point cloud about 10% of the size that it was before. So still sampled randomly across the point cloud, but it is random. Okay, so now we'll try thinning, see what the differences are. So close that out and then go to the thin function. A few different questions here. So let's select our original file again. And our output file, I'm going to call this area thinned. And the thinning value, let's type in 0.1 again. So this is going to be 10 centimeters. So now we have to think about this. This is going to do a uniform thinning across the entire point cloud. So in a 10 centimeter, if you imagine a 10 centimeter cube, it's going to thin and take either the highest point in that 10 centimeter cube or the lowest point or the average point. So let's just pick highest for now. And we need to choose, is it going to do this across is it going to also do this vertically in a 3D and create 10 centimeter cubes vertically and horizontally, or is it only going to do it horizontally? So let's pick 3D thin to do everything in a 3D manner. We need to select a temporary folder. You can just select the same directory. And now we can hit execute. So this process does take a little bit longer than sampling because it is checking little, in this case, 10 centimeter cubes for the highest point in each one, and it's going to take that in the end. So we should expect 1 point every 10 centimeters approximately in the cloud. Including in a vertical manner in the trees and the vegetation and stuff as well. So we'll just let this run here. It's almost done. There we go. So now if we look at this point cloud, actually while it's loading, you can see we went from 150 megs down to 81 megabytes. So we're gonna have a lot more points than the 10 centimeter sample, but they should be a little more uniform. So if you have huge pockets of clusters, maybe you drove past a certain tree or something many times and you have a very dense set of points, this will thin those out into a smaller uniform manner of 1 point every 10 centimeters in this case. I hope that helps. Have a good day.